All right, so we are now recording. Like I said, today is going to be a review session. Um, and yeah, so if y'all have specific questions, please go ahead and ask them while we're waiting on those questions to come through. I will just kind of give you some of the background about the exam itself. It will be kind of what you would expect a math-based exam to be. You will have to perform calculations and put those in. There will be some, I think there may be a couple multiple choice, but pretty much everything else is going to be, you have to actually put in the values. After you finish your exam, don't be surprised if it looks like you got a bad grade, because half the questions aren't going to actually be graded automatically. I'm going to go back in and take a look at what your answer was. Question is, let's see, what we'll be able to use on the test to help us. You can do a one-sided cheat sheet. So one page, just the front. So at the beginning of the exam, when you have to show your environment, show that cheat sheet, flip it over, make sure that there's nothing on the back. You can use that cheat sheet. You can have scrap paper, and you can have a calculator. Your phone cannot be a calculator. If your phone's on your desk, that's going to be perceived as cheating. So only use an actual calculator. You can get a really cheap one at like Publix for like $2. If you're not comfortable with buying a calculator, let me know and we can get you one. But yes, you can have a cheat sheet, one-sided cheat sheet. You can put whatever you want to on that cheat sheet. So if you want to work out a practice problem, you can do that. If you want to just do formulas, that's fine too, but whatever you want on that cheat sheet. All right, questions about the exam or the material? Amber said, I think you said that we wouldn't have to worry about upper and lower limits. I just want to confirm that. And if we do have to use them, can you remind us what's the questions? So if I specify that you should use the real limits on a question, use the real limits. Otherwise, don't worry about it. And I will explicitly say, use the real limits. Julie says, will the test only be math-based or will there be vocabulary? So, I mean, you need to know the terms and able to perform the tests, really. And so I would include, I mean, any terms that are relevant, I would know what they actually mean. Amber says, sorry, I don't know why, it makes me want to panic. Yes, don't worry, don't panic. Just think about real limits as being what you would round up to, round up or round down. How would we access the unit normal table? I will include relevant sections of the unit normal table on the exam. And so I won't give you the entire unit normal table. I tried to do that, but Canvas imposed a limit on me. So you're lucky Canvas is being nicer. So for each question where it's relevant, you'll get a section of the unit normal table. You'll get like one full point of z-scores. What is the extra credit you referred to on Canvas underneath where the exam is listed? Oh, don't worry about that. That's just for those who remind me that I'm not recording, or in the future when I've got extra credit to give out, that's where I'll put the extra credit grade. Cool. What other questions do we have?
I have a question about chapter 6, page 181.
Okay.
Can you hear me? Okay. So it says that in the last paragraph, it says that normal distribution is continuous, and but doing the binomial, like the flipping of a coin, that's discrete because there can't be any values between the different variables or values. But I thought that the binomial probabilities could be a normal distribution, which, I mean, so I don't know, I was just kind of confused because can't they also be a normal distribution?
Very good question. Give me 1 second here and I will pull up. Stop that share. All right. So the question was, when you've got something like a coin flip, they can't be continuous because there's essentially just a discrete variable, right? You can have one head, you can have two tails, etc., things like that. What you are using when plotting that distribution is essentially the splits of that. So let's say we flipped a coin 50 times. You would expect 25 heads, 25 tails, which would come up to 50-50, but you can have a spread there, right? And so if we look at this distribution, this would be an example of essentially all tails. This would be all heads here. And then you're getting the split of them. And you can see near 50-50 is where you've got the biggest frequency, right? So this is just frequency here. Where it's closer to 50-50 or 49-51 on either side, you're getting the most frequent responses. And so what you're actually plotting here is essentially just the, excuse me, the distribution across the different values. Does that make sense?
Sorry, yes.
Okay, perfect. Good question. What other questions do we have?
I have a question that has less to do with the material itself, but did you already cover how many questions will be on the exam?
I haven't, but y'all shouldn't have a problem with this one. This exam in the past hasn't really given much of a time pressure. I also don't know the answer to that question. So
okay.
It's not a ton. It won't be too bad.
Can you define what a binomial is again?
Yeah. So binomial, just break down the word, right? So bi meaning two. That just means there are essentially two options, right? And so if you think about a coin flip, you have heads or tails. If you're thinking about for an exam with multiple choice questions, you can either have correct or incorrect. And so binomial just means any sort of distribution that is dealing with two possible outcomes, left or right, heads or tails, correct or incorrect. Does that make sense?
That makes sense, thank you.
Of course. ¿Qué más? What else?
Are we gonna work out practice problems in this session, or we just?
Yeah, we can go over practice problems. Oh, sorry, I just
All right.
realized that there are people in the chat that didn't leave the chat box up. Can I ask about your 102 test at the end of class? Julie, email me offline and we'll talk about that. Alex says, you may have already answered this, but how will the test be formatted? It will be almost all like short answer / fill in the blank. I mean, you'll have to calculate the answer and then type those. Yes, we can work out practice problems. So, Caleb, did you have a specific practice problem you wanted?
I guess. I mean, I guess I would like to do more sample mean type questions.
Want to do more of what?
Sample mean, like standard error kind of questions.
Okay, yeah. So,
Difficult one.
so let's say we have, just go back to the IQ distribution because it's an easy one to work with. So here's our population.
Hey.
Oh. Yeah, I'm going to go ahead and mute you here. Sounds like you've got noise in the background. All right. All right, so we have our population distribution, and we know our population mean has an IQ of 100, and we know that the standard deviation for the population for IQ is 15, right? And so standard error is relevant when we say, okay, what's the probability that we're going to select a sample that has an average IQ of, let's say, 106 for their mean? And so we know a couple things, right? So we know our population has a mean of 100. We know our population has a standard deviation of 15. We know our sample has a mean of 106. And let's say we sampled 25 people. And so if we want to know what's the probability that our sample of 25 people would have an IQ of 106 or greater, we're going to take that a Z formula, which is for a single individual, it's just X minus the population mean over the standard deviation. However, for samples, when we're using the distribution of means, instead of X, it's going to be the mean, right? Because this is going to be our single point value, minus the population mean. And then instead of standard deviation, it's going to be standard error, right? And if you all remember, the equation for standard error is just the standard deviation over the square root of n, right? So to get this standard error down in here, we need to take the standard deviation, which is over here from the population, our standard deviation of 15, and we need to take the square root of n, and our n is here from the sample, square root of 25. So that gives us 15. The square root of 25 gives us 5, or 15 over 5 gives us 3. Right? So that's our standard error. So to put this all in, we replace our mean with 106, our sample mean. We replace our population mean with 100 there, and then for the standard error, replace it with 3. So that gives us 106 minus 100 gives us 6 over 3, or Z equals 2, and then you would go look that up in that unit normal table. So the standard error of the mean is essentially just replacing the standard deviation when you are getting the Z-score. Does that make sense, Caleb?
Yeah. I guess I was kind of leaning more towards like a question where we would use the X equals the mean plus or minus Z times standard error.
Ah, okay, so you want to find the actual value.
Yeah.
X equals the mean plus or minus the standard deviation times the Z-score, right? And so what this is saying is, if we know the population mean, we know the population standard deviation, and we've got a Z-score, what is that X value that corresponds to that Z-score? And so let's say, what are the two values that correspond with the middle 80% of IQ? So we've got that X. We're going to take our mean of 100 plus or minus that standard deviation. We know the standard deviation for IQ is 15. And now we have to go to our unit normal table to look up what the actual Z-score would be. So look this up, unit normal table. All right. Let me stop the share. Share the desktop. All right. So if we want the middle 80%, we want 10% in each one of the tails. We scroll all the way down, scroll all the way down, scroll all the way down, and we find that a z-score of 1.28 gives us 10% in each of the tails. So let's go back and share here. So we take that 1.28, sorry, 28, and so 15, come on now, 15 times 1.28 gives us 19.2. So it's 100 plus or minus 19.2. And so if we do that 100 minus that, 80.8. And the upper would be 119.2. And so this is telling us that 80% of the population has an IQ between 80 and 100, or 80.8 and 119.2. Is that more what you're looking for, Caleb?
Yeah, that was good.
Perfect. Of course. All right, I saw some other chat things pop up. Can we do a word problem that asks about the unit normal table that have to do with the proportion between mean and z? Sure. So let's think about when we would actually want the distance essentially between mean and z.
Somebody was asking about the normal table for that other question. I figure you probably want to answer them now instead of later.
Oh, perfect. Yes. So the, let's go back to sharing desktop. Perfect. So a word problem that would indicate you want the distance between the mean and z would be something like, so that wouldn't be a good example. It would be something like, what is the proportion of scores that correspond to, the top 10%, right? And so, actually, let me go back to the actual, share this. Come on now. All right, so if we have our distribution in here, and we said, okay, what is the proportion that falls below a score of, z equals 2.3, you know that 50% falls down there. And so you may want to get what is the distance from here to that mean to add to the 50%. Now, what would probably be easier is if you just did the entirety of the body. But the example I just did of the IQ scores, what are the IQ scores that correspond to the middle 80%? If you flip that and said, I've got, what are the, what proportion of the population has an IQ between, let's say, 70 and 130, right? So now we would say, okay, we know 70 is going to be somewhere down here. We know that 130 is going to be somewhere up here. And what we want is the proportion of that distribution that falls between these. And the best way to do it is to find what is the proportion that would fall between 70 and the mean, and add that to what is the proportion between 130 and the mean. Because you don't really, the other way you could do it in theory is take the full 100% and then just subtract this tail and subtract that tail. But that gets a little hairy, so I would just take, especially for this where 70 and 130 are equidistant from the mean, you can essentially just take what is the distance between the mean, from the value you're interested in and the mean, and multiply that by 2, and you get that proportion. Does that make sense?
Kind of.
Kind of. Do you know what may not, I realize this is such a tough question to answer, but do you know what may not make sense or where you're getting hung up on with that explanation?
No. Can you like make a word problem so that I can like, I don't know,
Yeah.
like an actual problem that would be on the test instead of explaining through it? 'Cause I feel like, I don't know, somewhere I just got lost.
So a word problem may look something like, what is the proportion, of students who have a SAT score between, let's say 900 and 1350. Shit, that went away. All right, I'm just gonna write it by hand.
Okay.
And 1350 given a mean of 1,000 and a standard deviation of 75. All right, and so now you have to find, okay, within this entire distribution of scores, with this being 1,600 and this being 0, I don't know if you can actually get a 0, but let's just say, this is the mean at 1,000. What would be the proportion that would fall between this 1350 and 900? Does that help?
Yes, actually it does.
Good.
Thank you.
Of course. All right. If I somehow scroll past your question in the chat box, feel free to call me an idiot and let me know. Apollonia, are those questions you want to work through, or?
Yes, those are practice questions from each of the chapters. Those are just a few that I got stuck on, but the others I could do.
Okay, let me go grab the book real quick. All right, chapter 2, number 17. All right, so for those of you all who can't see it, it says complete the final 2 columns in the frequency distribution table and then find the percentiles and percentile ranks requested. Is that the one you were looking at, Apollonia?
Yes.
Cool. 5, 4, 3, 2, 1, 2, 5, 6, 4, 3. And so want to find the percentile and percentile rank. All right.
And I don't know if you want to work the whole problem or not, but what I was really having problems with were finding C and D, just the 15th and the 65th percentile.
Okay. Frankly, while that is important for you to know in life, you're not going to have to know it for the exam. So if you want me to go over that, we can go over that.
No, thanks.
And I'm happy to meet with you offline to go over it.
Okay.
Since it's not on the exam, I don't see point in spending time doing that. All right. Chapter 4, question 17. All right, so this is the question where it asks for the following sample of n equals 8 scores. Simplify arithmetic by first multiplying each score by 2 to obtain a new sample, then compute the mean standard deviation for the new sample. So is that the question you're asking about, Apollonia?
Yes.
Okay. So all this is asking you to do is essentially compare what the mean and the standard deviation do once you get, or once you change a sample. And so when you've got 0, 1, 1/2, 0, 3, 1/2, 0, and 1. When you take each of these and you average them together, so 1, 1.5, 4.5, 5, 6, so the sum equals 6. 1, 2, 3, 4, 5, 6, 7, 8. And so the average, so the mean for this would be 6 divided by 8, or 0.75. Saying if you multiply each of these by 2, what does that average become? So when you multiply by 2, I get 0, 2, 1, 0, 6, 2, 1, 0, 2. So now add all of them up, 2, 3, 9, 10, 12. 12 divided by 8 still. And now that gives you 1.5. And so this is asking you essentially to just know what happens when you multiply every value by a set
2.
value. Yeah, exactly. And so if you know how to calculate the mean, if you know how to calculate the standard deviation, think about just conceptually what happens when you multiply or when you add to a certain value. So going back to our examples before, what happens when you add a fixed value? What happens to the standard deviation?
You add this, oh, never mind.
So when you add a value, the standard deviation doesn't change, right? The mean will change up by that amount, but the standard deviation won't change. So what happens when we multiply by a set value?
Then the standard deviation does change. It broadens, doesn't it?
It does, yeah. And so when you multiply values by a fixed amount, the mean changed by that multiplication, right? So you just essentially doubled the mean here. And same with the standard deviation, right? So, I mean, you can work out these problems to figure out what the mean and the standard deviation is, but as long as you know that rule of thumb, you'll be good. Does that help, Apollonia?
Yes, thank you.
Of course. Erica says, is all the information we've learned so far going to be on the test? Nope, everything we've covered is fair game. Maria says, are we expected to sit for the exam at exactly 1 p.m.? Nope, it'll open at midnight Wednesday morning, and we'll close by 11:59 Wednesday afternoon. You'll have 80 minutes to take it once you start taking it, unless given extra time. And so, you know, once you start taking it, don't plan on stopping it and coming back to it later. The clock will still be running. And if you started at 11:30 at night, you're only going to have 29 minutes to finish it.
Is it, are you able to go back and forth between questions, or once you submit that answer, it's done for?
So I think I have it set such that they'll all be displayed on the same page. So you can just scroll back.
Gotcha.
Julie says, when putting an answer in for a z-score, do we have to type a plus or a positive z-score? I don't remember what I had, but if you just don't put any signifier in front of it, I'll just treat that as a positive. So put a negative if it's a negative. Otherwise, you'll be fine. Ace says, why 1.28? Sorry, Ace, I didn't mean to neglect that question until just now. 1.28 because we have 10% in each of the tails, right? And so if we are interested in the middle 80%, you want 10% on either side, which gives you the 10%, I was sharing, which gives you the 10% in each tail here. So this is above the Z or in the tail, 10% corresponds to 1.28. Oh, awesome. Thank you, Caleb. Man, I should really go through and read the rest of the answers y'all have. No, these questions are not from a review study guide. There's no study guide for this exam. Do we need to download any of the proctoring software? Yes. Yeah, go online, type in UAH, lockdown browser, and I think the first thing that comes up on Google should be the Canvas page that gives you all that information for it. Could you write out right now what formulas we will need? Sure. I'm not going to actually write out the formulas because I don't want to just give you all your cheat sheet. But so know how to calculate from X to Z, how to calculate from Z to X, same things with mean to Z, and from Z to mean, know how to calculate the mean itself, know how to calculate the standard deviation, know how to calculate the sum of squares, how to calculate the variance, how to calculate the standard error of the mean. Hope y'all didn't see how clumsy that was. There's a reason I went into academia and not any form of athletics. Let's see, what am I missing here?
What about the PQN and stuff
Oh,
like
yes.
that?
Thank you. Yeah. So for the binomial distribution, understand the probability for the binomial. And so, knowing how to calculate Pn, Qn, P, Q. So, after the variance, that's standard error of the mean, Erica. So what we covered, I guess, last class. I think that's it. I'm racking my brain. If anybody knows of other ones that I'm missing. Kate, if you have any questions about a specific formula or how to work it out, I'm more than happy to go over that. So when writing out numbers with decimals, do we need to go out to 2 decimal points or more? So wherein I've got the system automatically grading for me, it'll have a window. And so, it doesn't, in theory, matter if you go out to 100 decimal points or 2. But a good standard, I think, as long as you do 2 decimal points. You should be good. Yes, you can have scratch paper. Ace, we practice review questions on MindTap. Would that prepare us for the test? Yes. That's not the only way. So if y'all did get MindTap, don't worry, there are other ways to do it. But yes, that could be. Under PN, is that Q standard error? No. So that Q is just, so when we think about the probabilities, P is the probability of, for example, correct answers. Q would be the probability of incorrect answers. Alex says, is the entire test calculations, or will there be questions about statistical terminology? As I said earlier, I think it's next to impossible to do the calculations without having kind of the conceptual understanding and definitional understanding. I don't remember. I think there are a couple questions that say essentially define and give me an example. So can we download the software now, or do we need to do it? No, you can download it now. What is the other way to prepare for the test outside of MindTap? So the nice thing about statistics is it's pretty standardized across universities. And so there are a lot of practice examples you could find from other places. There are probably even old exams, not of mine, but of other professors out in the Google sphere that you could find and practice on. And frankly, if you just type in, sum of squares practice, that would be a great way. Going through the questions in the back of the book would also be another great way. Yeah.
Could I get a refresh of the conceptual understanding of standard error? Like,
Yeah.
why is it, yeah.
Absolutely. Absolutely. So let's start from square one. So let's say this is our population, right? So let's just make this everybody that's alive right now. We have, and let's call this of height. So we have 7 billion people in this population here. And if we want to get the kind of average, we don't want to get the entire population, or if we want to see, okay, are UAH students taller than UAB students? We don't want to get, all 10,000 UAH students. And so what we're going to be doing is taking samples from this population. So, we sample a group of people here, and from that sample, you're going to have a mean. So let's say that mean is 5'7". You're then going to throw all of those people back, and you're going to get another sample. Let's say that mean is 5'6". You throw all those people back, get another sample. Let's say that mean is 5'2", etc. And so, based off of just the function of creating means or calculating these means, that is not a very good standard deviation, or distribution, but that when you take each of these means, so you've got mean down here, 7, oops, mean there, you've got a mean there, that these are going to be kind of tightly grouped around what should be the population mean, right? So let's say the ground truth is 5'6". You can see we actually have one sample here that is right at that population, but we've also got other samples that are relatively close, right? And they create their own distribution, right? We call this the distribution of sample means. Why is it error? Yes, all right, so I will explain that in just a second. So we've got each of our means in there, and what we're interested in is essentially how close is any individual data point to what is the ground truth. And the ground truth in this case is that 5.6. And we call it the error because it's essentially a sampling error, right? If we pull out what should be a representative population, or excuse me, a representative sample from the population, it should always be 5, 6. But there's always going to be some change in that, right? So you're going to get the 5, 7s, you're going to get the 5, 3s, etc. And so we call it kind of that standard error of the mean because it's like a standard deviation, except we're not really measuring deviations, we're measuring sampling error, right? We're measuring the error of our test because it should be here, but in reality, it's right here. And so we're getting that standard error, that standard distance away from that ground truth, and that's the error that we're accounting for. Does that help, Kenya?
Yeah, that helps a lot. Thank you.
Good, of course. Yeah, I mean, there are a lot of things I think if we were to start all over again that we should rename stats things, different things, but they're so ingrained now that they're a little confusing, describing essentially the same concept, but.
I had a question.
Yeah, Sonny, what's up?
That question about the middle 80%, I just want to understand why you have to check for the 10% when they ask for the 80%. Like, why are we concerned at all with the 10%?
Yeah.
When the question.
So let's say we have our population distribution here, right? And we know that because it's the population distribution, it encompasses 100% of the population, right? And so if we want the middle 80%, we don't want the 20% at the extremes, right? So the 20% of this end down here and the 20% combined. So the 20% from this end and this end combined, right? And so if we want the, in fact, middle proportion, we know that if we have 20% at the extremes and we want to find the middle, we need to find, okay, what amount of that 20% goes onto the extremes, and we're going to assume that it's equally distributed in the extremes. So to get the middle 80%, we take 10%, we put it there, we take another 10%, and we put it there. If we did 20% on each side, that would only give us 60% in the middle, right? Because then we'd have 40% at the extremes. So because we're interested in the middle 80%, we're going to exclude the extreme 20%. And to do that, we need to split that 20% up evenly into each tail. So that's where we get that 10%. Does that make sense?
Yeah, but then why wouldn't you just check for 80% in the unit normal table?
Because there's no 80% between these 2 points, right? And so if we go to the actual unit normal table, all right, so if we go to the unit normal table, go ahead.
What I don't get is if you're supposed to search for the middle 80%, that's the question. You want scores for the middle 80%.
Yes.
So why does the entire question revolve around 10%? The 20% that is not supposed to be used, I guess.
Because there's no column in here that tells you the middle 80%, right? So this column right here gives you closest, right? Because it's saying 40% on each side of the mean. But because you want the 80% and you need to find what that z-score is, to find that z-score, you need to exclude what that extreme is, right? And so the easiest way to do that is to find the tails, because even this first column, this is just percentage in the body, right? And so if you were to take this first column, let me do a new share real quick. If you were to take that first column, all you'd be doing is throwing that 20% all, excuse me, in one tail. And then we're not looking at the middle 80%, right? We're looking at the bottom 80%. Because we want the middle, it has to be equally weighted on both sides, right? So instead of that 20, we're going to take that 20 and we're going to put that 10 on either side. Or you could just do it and say, okay, what is the value for which the distance from the mean to some z here is 40% on this side and 40% on this side, right? You're going to get the same value, the same z-score. It's just kind of a framing question.
Okay, thank you. That makes
Yeah.
more sense.
Okay, good. What other questions do we have?
I was wondering, there was a question at the beginning that was like, what is the average IQ of the middle 80% or something like that? And like the sample, there's a sample, blah, 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 of like mean 106, number of people 25. And we got the answer where it was 106 minus 100 over 3, and then the z equaled 2, right? But because it's the middle 80%, because that's part of the question, you look for, the 10% tail, right? But then why
Ace,
did
I think
we get...
Ace, I think you're combining two different questions. So that first question was, let me see if I've got. Yeah. So here we're saying, what is the probability of getting a sample with 25 people that has a mean of 106 or greater? So this is not a middle 80% question. This is just we took a sample of 25 people from the population with a known mean and a known standard deviation. What is the probability that we would get this score of 106 or higher? And that's where that z-score of 2 comes in. So then we go look up that value in the unit normal table. And so we scroll all the way down. The proportion above that z is 0.0228. So 2.28% chance that we would get a sample of 25 people with an average IQ of 106 or greater.
Oh, okay.
Does that make sense?
Yes, it does. Okay, thank you.
Yeah, I can see why you would be.
Yeah, you can see why I was confused if I was combining two questions.
Yes. Yeah, that would be very confusing.
Okay, cool.
What else?
I've got a question.
Yeah, what's up?
Okay, what's the formula again where you get, you have X and you're trying to get Z?
When you have X and you're trying to get Z is, I wrote that down here somewhere. Screw it, I'll just do it again. All right, so when you've got X and you want to get Z, you have to take the X value you want minus the population mean divided by the standard deviation. Now, if instead of a single person, you have a sample of people, this equation then becomes the mean of that sample minus the population mean over the standard error of the mean.
For
Yes.
some reason, I know the second formula better than the first one. I just need to focus on the first one.
Yeah, so I mean, this
Focus on learning the first one, I mean.
yeah, this is essentially saying the same thing. It's just, what is your value of interest? In this case, your value of interest represents one person with the X. In this case, it represents one sample with the mean. And then this is still essentially a deviation measure on the bottom. It's just it just differs of, are we talking about the population or are we talking about the distribution of sample means like we have here on the bottom? So.
Okay. I mean, if I remember one of them, I should be able to work backwards and get the other one.
Exactly. Yeah. I mean, it's doing the exact same thing. It's just different letters.
Yeah, okay. Thank you.
Of course.
Based on her question, I had a question.
Mhm.
So, would there ever be a question where you don't have X and you don't have the Z at the same time?
So I would say essentially find the Z, but I don't give you the X.
Like when you don't have both, would there be a question like that?
So you'll always have at least one of these. You'll always have at least Z or at least X.
Okay. So also, what kind of question, like how would a question look like if we had to find the X, but we had the Z?
Yeah. So like, what would that question look like, or what's the formula for that?
Yeah, what would the question look like?
So if you wanted to find the X, but you had the Z, so that would be, what are, I'll just write it here, are the scores which correspond to the, actually I'll say, what is the score that corresponds to the 90th percentile. And so in this case, it's saying essentially find what z-score corresponds to 90% in the body or 10% in the tail. Once you have that z-score, then plug that in to find the raw score. So that would be that population mean plus z times the standard deviation. Does that make sense?
Yeah, thank you.
Of course. What else? Evan says, so for this example, we would find the z-score in the tail. Yes. Well, I mean, so essentially, it doesn't really matter because this z-score here is giving you the same information for 10% in the tail and 90% in the body. You just need to find that z-score, which corresponds to that point. But yeah, you would look it up in the unit table. Yep, of course. Yes. Is that table something we have to put on the cheat sheet? You mean the unit normal table? No. So I will give you relevant sections of that unit normal table on the exam. What other questions do we have? Is everybody stoked to take this exam? Notes are not allowed to be used on the exam. You get one page of cheat sheets, and that's just the front, not front and back, just the front. Amber, I suspect that was a sarcastic answer, but I'll take it nonetheless. Oh, don't be scared. You'll be fine. Stats should be the least scary class you take. It's completely objective, right? You know if you add 2 and 3 together, you get 5. So you'll be fine. Numbers are bad. Get out of here. So where is this table that we get to use? So the table will be on the exam. Like I will give you the actual values on the exam.
Will it be like, will it just be like associated with the question or?
Yep.
Okay. As I wanted to make sure we weren't looking through like the big table that you're using to find all the Z-scores.
Well, you'll have to look it up. I mean, I can't give you the full table because
that's what I'm saying is using like something of that large to go through for each question rather than something associated with the question itself.
Yeah, it'll probably be like 20 rows rather than the full however many rows. Numbers aren't spooky. Numbers are great. Numbers allow you to figure out the truth of the world. Mathematics is exciting. Of course, Amanda, happy to do it. Truth, that's true. The world is a little spooky. Oh, yeah, come on in. All right, what other questions do y'all have? I'm stoked to have this test done. Sure, we'll count that. Any excitement I can garner about statistics, I'll take.
Okay, just to make me feel better, because I can't remember what these questions look like.
Mhm.
Can we go over a question where you have the Z-score and you're finding the mean?
Yes. Well, so you won't have to find the mean from the Z-score. Oh, you mean like the sample mean, right?
Yeah.
Okay, yes, yeah. So the equation is just the same as with the X. So to find that mean, you need the population mean plus or minus the Z-score times, instead of the standard deviation, that standard error, right? So you will take whatever that, so let's, again, just go back to IQ because this is always the easiest to just work with. Population mean of 100, and then we will say, let's say it's the top 10% again, because we know that corresponds to a Z-score of just 1.28. And then you're going to have to find this standard error. And so if we know that for IQ, the mean is not only 100, but the standard deviation is 15, you then have to plug into this equation here, right? So to get that standard error of the mean is just the standard deviation over the square root of n. And so let's say this is a sample of 100 people. So now you're taking that 15 over the square root of 100, or 10, which just gives you 1.5. So 1.28 times 1.5. And so if we do that, we get 1.5 times 1.28, 1.92. So this gives us 100 plus or minus 1.92, or 98.8 and 101.92. Sorry, that should be, yes, wait, no. 08. Here we go.
Wait, did we already have Z when we started out? I forget.
Yes, yeah. So I just kind of made this up. I said, what would be the mean value if you had in the top 10%, or a z-score corresponding to 10%. But in this case, yeah, I mean, you would get it just from that unit normal table, or I would give it to you in that case. So anytime you're trying to solve for mean or you're trying to solve for x, I'm always going to give you the z-score because you can't calculate it otherwise.
Okay. Thank you.
Of course. Good question. So am I going to scale the test for everybody but you, Ace? I will. Just kidding. Yes. So the top performer, yes, thank you, Daniel. Yeah, so the top performer is always going to get 100%. So Nancy says capital M stands for sample mean, and the lowercase your looking symbol stands for the population. Yes. Yeah, so mu, that lowercase Greek symbol that looks kind of like a U, that is population mean. That is sample mean. Sorry, I should draw it more definitively. That M is sample mean. What else?
So if they had a question where you had to look for like what's the probability of getting 10% or less, does that mean you would then look in the body or still in the tail?
So if it was, you know, what is the probability of getting a score in the top 10% or less? That would be the body. Yep.
Why would that be the body?
Because if I'm saying here is, I want to know what is the probability of getting in the top 10%. So we know it's on the right-hand side, right? Top 10%. But we want to know what's the probability of getting that or less, right? So less would just be to the left, right? They're always decreasing when you're moving to the left. And so that would be that. If I said, what's the probability of getting 10% or more, that would be the tail. So more over here, less over here.
Okay, thank you.
Yep. Does the standard deviation symbol with the M mean standard error? Yes. Yep. Thank you all for chiming in and answering questions on the chat. It's a little strange to do this completely virtually, but I appreciate everybody kind of chiming in.
So when I'm doing problems, I tend to take up a lot of space on my paper. And I know you said we got a scratch piece of paper.
You can have scratch pieces. Yeah.
More than one?
Yes.
Okay, cool. Because if I get all mixed up, it gets too.
So when it comes time to the exam, the system will ask you to show your environment. Just show that the cheat sheet you've got is only one-sided, and then just quickly kind of rifle through the remaining scratch pieces of paper just to show there's nothing else on them. But yeah, you could, and if you want to have an entire notebook, that's fine.
Awesome, thanks.
Mm-hmm. About 15 minutes left. What other questions do we have? Good. I'm glad, Caleb. Yes, the goal of this exam is not to trick y'all. If you can do the examples we do in class, you'll be fine.
So are a lot of the, basically, are they going to be, so the examples that we do in class, they're going to be basically worded within the same way, or is it kind of like the same setups that you've given us, like the examples during class, or are they just going to be pulled from like a test bank or something of that nature?
No, they will be all very similar to what we've done in class.
Okay, yeah, that's what I wanted to make sure.
There will be differences in wording slightly, but it'll be very similar.
Yeah, that's what I'm saying, is if it's a total completely different wording of like the same concept that we did an example of in class.
No, I wrote these questions, so they should look pretty familiar to you. Anything else? All right, well, good luck studying for the exam. I know first exams are always anxiety inducing, and for whatever reason, statistics seems to induce even more anxiety amongst a lot of folks. So don't worry about it. Practice problems similar to what we did in class. You can create your own practice problems and find the answer in SPSS now that you know how to use that. Yeah, if you have any last minute questions, let me know. Don't email me the morning of the exam and expect me to be able to get you an answer by the end of that day. I'll certainly try to, but stuff always comes up. And so I can't promise that if you email me the day of the exam, I'll be able to give you any answers. So with that, I'll go ahead and stop the recording here.